I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. So, welcome to the lecture session of image processing. In this session, we will be discussing about components of image processing system. So, in the components of image processing system, we are going to discuss what are different hardware and software devices that will be used during this image processing system. Now, so this is the simple block diagram which shows different components of image processing system. So, among all this, some comes under hardware aspects and some comes under software aspects. Now, in this session, we are going to discuss about all these components in detail. So, in this figure, we can see the first one is problem domain, that is on which problem we are working, and different components we can observe here. One is image sensors and image processing hardware, computer, hard copy device and image displays, mass storage systems and image processing software. And along with all these blocks, one more important thing we need to discuss is about network. So all these are different components of image processing system. So now we will be discussing about each block in detail. So the first one is problem domain. That means on which problem we are going to work on. Based on the problem, we are going to take what type of computer is required, how much amount of memory is required, and what is the software we are going to use, and what are different hard copy devices that we can use, and which image display is better in order to see that particular images. So it completely depends on the problem domain. Now, so if you see here, the first fundamental and important component is first we require an image on what we are working. How that image we are going to get with the help of this image sensors. After we have the image only, then all the remaining blocks that are available here will come into action. So first and foremost fundamental block we are going to discuss here is image sensors. Now, so the first block, the fundamental block here is image sensor. So generally, in order to acquire any image, these image sensors are very helpful. So what are different things that will be available in this image sensor? One is sensor, another one is digitizer. So what the sensor will be doing and what the digitizer will be doing here? Initially, the sensor is very sensitive to the energy radiated by the object we wish to image, whereas the digitizer is a device for converting the output of the physical sensing device into digital form. So initially here the sensor, soon after getting captured the image with the help of digital camera, that particular thing will be in the form of electrical signal. That particular electrical signal will be converted into digital form with the help of digitizer which is present inside. So for example, you can take digital video camera. So this digital video camera is the basic example for image sensor. So the sensors in this particular application, the sensors produce an electrical output which is proportional to the light intensity, whereas the digitizer is going to convert that particular output into digital data. So this is the main function of this image sensor. It is going to capture the image and it is going to convert it into digital form. And that particular image will be given to the next block. So here the next block, the next component here available is image processing hardware. So this image, so here the name itself says some hardware will be present inside. We will discuss what is that hardware. And in this block also, we will have one important component which is called digitizer. It is going to have digitizer because it is going to take the input image as a digital image. Along with that, we will also have some hardware present. So the function of this hardware is it is going to do basic operations such as ALU. Hardware here is ALU, Arithmetic and Logic Unit. So what this ALU will be doing for that particular image means it is going to perform different arithmetic and logical operations on the entire image parallelly. So different arithmetic and logical operations will be done on the image using this hardware unit, that is ALU, and the operation will be done on the entire image parallelly. So ALU is used for averaging the images quickly. Why? Because the operation is completely done parallelly on the entire image. Main purpose is here noise reduction. So here hardware can also be called as front-end system, and the most important characteristics of this hardware is in order to process the image, the speed of operation should be high. That means ALU should do the operations very quickly. So here in this image processing hardware, main components that are available inside is one is digitizer, another one is hardware, that is ALU. And the next component is computer, which is the basic one. So after capturing the image, in order to do any operations or in order to apply any algorithm on the image, to do any operation, so here computer is must. So generally here we can use any general purpose computer or special purpose computer or customized computer. It is completely based on the application on what we are working. So as the application is very hard, we have to go for using some special purpose computers. But basically whatever we are doing is some general applications. So the normal PC, which is called general purpose computers, are sufficient. So the computer in an image processing system is general purpose computer, and the general purpose, which type of computers we call as a general purpose computers means it will be ranging from PC to supercomputers. So which type of computer we have to use? It is completely based on the problem domain, that is on the application what we are working. So in dedicated application, some will be going for designing some special computers, because in order to reach that particular level or in order to improve the performance, this particular special computers are very necessary. But our interest here, the application what we are doing here, by using general purpose computers, digital image processing is suitable. So in these systems, almost a well-equipped PC type machine is suitable for performing the offline image processing tasks. So for it is the type of computer what we are using here is completely dependent on the application on what we are working, how complicated the application is. Based on that, we can prefer the general purpose computer or some designed computers. And the next important one is softwares. Okay, so image processing software. So here we are going to have some specialized modules, the image processing softwares. Some of the softwares, it will consist of some specialized modules which are going to perform some specific tasks. So a well-designed package also includes the capability for the user. So what are different operations that particular user can perform using this feature means the user can write a code, and also the user can use some specialized modules that are available in that particular software. So more sophisticated software packages that are available now. Generally what we are working on the digital image processing, and it is integration of all the things. That means the modules, different modules are available along with general purpose software commands, so that some operations, the programming can be done in order to perform image processing tasks. So nowadays whatever the packages that we are available here, all these things are integrated. And the next important component is mass storage. That is the amount of memory that particular image is occupied. What is the internal memory and external memory that is available. So it is must in image processing applications. That means here image processing means we are working on images. So we need to store that particular image or processed image, or we need to transmit that particular image. So in order to store the image, it requires amount of storage. In order to transmit the image, how much amount of bandwidth it is being occupied. So these things we have to see in this mass storage. So it is must in image processing applications. For example, if we take one image which its size is of 1024 by 1024, that means these many pixels will be available in that particular image. So out of these many pixels, each pixel will be represented with the help of 8-bit quantity. So in order to store this given size of image, approximately it requires 1 megabyte of storage. If you are not going to compress that image, it is going to take 1 megabyte of storage. That's why we have to compress the image and we have to store, so that the area occupied by that image will be reduced. The memory occupied by the image will be reduced. As we are talking about single image, this is the thing. If we, while working on this image processing, we will not work on the single image. We are going to consider some thousands of images. In such cases, if you want to store one image, if it requires this much amount of data, if you are working on the thousands of images, what about the storage capacity? The storage capacity should be increased. It requires high amount of storage. Then it becomes a challenging task. Generally here, storage will be measured in terms of bytes, kilobytes, megabytes, gigabytes and terabytes. So generally in order to store this digital images, or when we are working with digital image processing applications, here are the three categories in order to store the images. So here the three categories are, it may be short-term storage, or it may be online storage, or it may be archival storage. So when we call as a short-term storage, it is used only during processing. Online storage means if we want any in order to fast recall the image, then we will go for this online storage, or this archival storage characterized by infrequent access. And the next component in this image processing system is hard copy device. That means once the image is processed, in which we are going to store that processed image. hard copy devices means we can go for pen drives or CDs in order to store the processed images. So once the image is processed, then it will be stored in a hard copy device. That hard copy devices may be either pen drives or you can go for external ROM devices. So not only these, there are also different types of hard copy devices. For example, laser printers, film cameras, heat sensitive equipment, inkjet, printers and digital equipment like optical and also CD-ROM discs. All these comes under this hard copy devices. So any of these can be used in order to store the processed images. And next important thing is image display. So once if the image is processed, we have to see the processed image. Then this image display comes into action. So to see the processed image, we have to display that particular image by using the display. Either it may be monitor. So it includes the monitor or display screen on which the processed images are shown. To see the processed images, we are going to see that in some displays like monitors or display screens. Okay. So image displays are mainly colored TV monitors. And the last important one is here we have to speak about network. That means if the image is processed, it should be transmitted through the communication channel. So we should also see that how much amount of bandwidth it is occupying during transmission, and also to transmit what about the network capacity, whether it is good or whether it is bad. What are the constraints that are making it good and what are the constraints that are making it limited. Now, so speaking about this network, it is the default function in any computer that we use today. That is, all of us are using internet in order to transmit the images. So because of large amount of data that is used during image processing application, this bandwidth is a key concept. Okay. So as I have already discussed, what is meant by bandwidth? Amount of data that can be transmitted by using the communication channel within specific amount of time. For example, if you take some dedicated networks, then in order to transmit the image, there will not be any problem. But if you go for some remote sites, in that places the internet availability will be very low. In that cases, it is not always very efficient. So now fortunately the situation is good. The internet facility is very high and we are having good internet. So the result of optical fiber and other broadband, by using all these technologies, by using the network, the image can be safely transmitted. So not only these constraints making the network, some of the constraints we need to also see is as we are working on the image, we should also see some important characteristics on the related image and network, like what is the file size, what is the transmission technique we are using, and also what is the transmission speed, what is the compression technique we have applied on the image, and also something like network latency, what is the quality of service. All these things also we should consider while discussing about network. So in this session, we have discussed about what are different components that we are going to use during image processing system. So here the content we have taken is from Digital Image Processing, which is written by Gonzalez. Thank you.
Like, share and subscribe. hit the bell icon for more updates.